Lesson 8.1D, Permutations. A permutation is an arrangement or listing of objects in which order is important. You can use the fundamental counting principle to find the number of possible arrangements. So we've been talking about probability and possible outcomes. This will also tell you the possible number of ways certain things can happen. If we start talking about combinations, that would be something where order is not important, but the important thing for you to remember about permutations is order is important. The order is important. It makes a difference where certain things end up. The way that you do permutations is you're going to be doing a lot of multiplying. When you see something like this, find the value of 5 times 4 times 3 times 2 times 1, that's also written like this, 5 with an exclamation mark. It's called factorial. And if you've got the right kind of calculator, it'll calculate a factorial for you. Some of your calculators, you might see n with an exclamation mark beside it, and you put the number 5 in there and hit that button, and it'll do this calculation for you. Everybody should be writing notes.
Okay.
So 5 times 4 times 3 times 2 times 1, if you multiply all that together, you get 120. So if I put 5 factorial in the calculator, we would get 120. If you only did 4 factorial, or 4 times 3 times 2 times 1, that's just 24. So these can get pretty large pretty quickly as you're multiplying them together. Now here is an example of a permutation. How many ways can 4 different books be arranged on a bookshelf? So if I had 4 books sitting here on this desk, they're 4 different books, and I have a shelf that I have to put them on. So how many different choices of books do I have to put up on the bookshelf first? How many books are sitting here on the desk? 4. So you start with 4. Then you put 1 book up on the shelf in the first spot. How many books are left on the desk to put in the second spot? 3. So that's where they get the 3. Okay, they have the 4, then the 3. They put 1 book up on the shelf. How many books do we have to choose from for the next spot? 2. So they have 2. And then finally, the last spot, there's only 1 book left. But if you take 4 times 3 times 2 times 1, there are 24 ways to arrange the books on the shelf. That's what you're going to need for some of the probability that you could come up with soon. Nico. It's how many possible ways can you put 4 books on a shelf? 24. Okay? Liam.
How would a word problem be written out if it was like this?
Just like this right here. How many ways can 4 different books be arranged on a bookshelf?
So we would do the factorization where you would do 4 times 3 times 2.
You'll do 4 times 3 times 2 times 1. That's what you would do.
That's not
That is
No.
easy work.
Question, Caden.
That's the same for all numbers, so like if it starts with like 10.
It just depends on what the question is. That's what we're going to get to. Okay, hold on a minute. We'll see. We'll get to the questions. They may not want all 4 books. They might have 20 books and you only have spot for 5. So you wouldn't go all the way down to 1. You'd only use 5 slots up. So you'd have 20 for the first spot, 19 for the second, but you only do 5 because you only had 5 spots. So it just depends on what the question is asking. This is just a very basic problem. How many ways can 4 different books be arranged on a bookshelf? Okay, so you're going to get something similar to that. Let's look at some of the examples that we have to do. The very first ones, and you'll probably have some of these, is they will have you multiplying just the numbers together, 3 times 2 times 1. And that's just practicing before you start doing some of the word problems. So if we had 3 times 2 times 1, what's that going to be? 6. What about this one? I'm not going to do, well, 6 times 5 times 4 times 3 times 2 times 1. Anybody know? Anybody got that one?
No.
Probably not sure, huh?
720.
720?
I think. Ow, my ears.
So it is 720. Now, if you look at number 4, this is kind of what I was talking about. There must be 9 possible things, whatever this problem is dealing with. There must be 9, maybe let's say 9 books. But they only have enough for 3 of them on a shelf. So how many different ways can you do that? So you would do 9 times 8 times 7, because there'd be 9 choices for the first slot, 8 for the second, and 7 for the third. So you'd have to do 9 times 8 times 7, 504.
That was 144.
504. All right, so these are some typical problems now. Number 5. How many ways can you arrange the letters in the word group? So how many letters are in the word group? How many letters are there? Caden? 5. So for the first spot, you have how many choices?
120.
Well, let's do that. Let's do each slot. So for the first spot, you have 5 letters. Okay? What about the second spot? 4. And then after that, the third, and the fourth,
2,
and the last.
1.
So 5 factorial, basically, and Caden said 120 ways. Okay, number 6 is a little different. It's similar to the one where I said they may not have use up all of the spots. So how many different 4-digit numbers can be created if no digit can repeat? No digit repeats. Remember, a number cannot begin with 0. How many 4-digit numbers can be created? So we've got the first spot, the second, the third, and the fourth. Some of this is kind of tricky. No digit can be repeated. But remember, a number cannot begin with 0. How many single digits are there?
10.
There's 10. If you go 0 through 9, there's 10. But they're saying for this first one, it can't be 0. So 9. So let's say they picked one of those out. Okay? They picked one of them out. Now, for the second spot, 0 can be here, can it? So how many really are there for the second spot?
9.
Back to 9. Back to 9. Okay, now we've used that one up. How many are left for that third spot now? And then how many for the fourth spot? Okay, this was a really odd problem, the way that worked out, because a number cannot begin with 0. Normally they do this and they say stuff like, how many, they'll give you a lottery system that uses numbers 1 to 70, and how many possibilities are there for you to pick from, or something like that, where you use numbers 1 to 70 or something like that. So this one where it can't begin with 0, you can't count all 10 digits for that first spot. And this is very unusual that you repeat those first 2 numbers. But do you understand why it's 9 twice? So you really have to think about that, because you can't have 0 on the first one. That takes only 9 numbers, 1 through 9. The second one, the 0 could be used, but they've already used 1 up in the first spot, so it's still 9 again. So we would have 987 is 504, but we need to take that times what?
9.
Another 9. So 4,536 possibilities. 4,536 4-digit numbers. That's a lot of numbers, isn't it?
Yeah.
All right, questions about that?